Hey guys, so we will be solving the valid Sudoku problem today, lead code number 36. This is a great problem if you want to familiarize yourself with two-dimensional arrays and how they work. I will be coding up the solution in Java, but of course the language shouldn't matter. I chose Java because of its verbose nature and statically typed syntax. I believe helps with readability, but you can choose to translate it into any language of your choice. So if you look at the problem itself, what it basically says is determine if a 9 by 9 Sudoku board is valid and check if the filled cells satisfy the three conditions that are present here. So the conditions are basically that we have 9 rows and 9 columns, and in each row we should not see any repetition of a number. Basically, since 5 has appeared here in the first row, we should not see 5 in any other column again, and the same thing for the column as well, since 5 has appeared at the first column itself. In this particular column, since 5 is at the top, we should not be seeing 5 anywhere in the whole column. So the same thing repeats across all the 9 columns and all the 9 rows basically. So that is the idea. And then there is a third rule. Basically, it says that we have 9 3 by 3 sub boxes, and each must contain the digits 1 to 9 without repetition. So as you can see, marked by bold lines, the Sudoku board can be divided into 9 non-overlapping boxes, and each box is supposed to have its own rule present where there cannot be any repetition of character. So here you can see there's 5, 3, 6, 9, and 8, and there is not a repetition of a single character. If there was a repetition, then the Sudoku board would be marked as invalid at that point, right? So we will come to the third condition later on, since it's a bit tricky. But let's start with the first two conditions since they're fairly straightforward. So the idea is that we will be iterating over all the rows and all the columns. So 5, 3, 7, and so on. So every time we go across an entire row, we mark every cell at that particular point if it's visited or not. So since we've come across 5 here, we'll say that uh, the first row containing 5 has already been visited. And if we again come across a 5 at that point, we'll say that it is essentially false since there should be no repetitions. Same thing for the column as well. We see a 6 here, we will mark it in the column as 6 has been visited. And if we again come across a 6 in the same column, let us say, then we essentially mark it as invalid. So ideally, we will be checking every single cell in the whole board and marking them as visited accordingly. So let me quickly take two arrays to do this, one for rows and one for columns. Since we know that the number has already been hard coded to 9, we know that the Sudoku board doesn't exceed more than 9 characters. We can basically create two Boolean arrays to check if whether or not the board is visited or not. So the next step is for us to start iterating. So let me just go over the outer loop, and same thing for the inner loop. So here we can see I don't have to write board.length since I know that it is 9 already, right? So since we have our iteration with us, the first step that I need to check is my base case, where if we have an empty cell or if it is a number in the first place, we'll only execute our logic if it is an actual number. If it is an empty cell which is represented by a dot character, in that case I do not have to do any business logic. So first thing I need to check is if board of I and j is a dot character. In this particular case, I can just continue. I don't have to do any business logic. Now, since I know that whatever character I'm left with is going to be a number, let me just convert the character into a number. So let me just do this. Int number is board of I into j minus of 0. Actually, we'll have to subtract it by 1. The reason is because all our arrays are basically zero indexed arrays. So if I have to check for 1, I should ideally be checking for 0. If I have to check for 9, I'll be checking for 8. since my array is only up to 9 elements, that would essentially be 0 to 8 and not 1 to 9. So I'll be subtracting every number by 1, which essentially means that I can reduce every single digit by 1, so I can track it against a 0 indexed array. So our first condition is basically to check for the rows if it is actually visited or not. So if rows of I and num is equal to true, in this case I will be returning it as false. Since it is already visited, it is an invalid Sudoku board. And if it is not already visited and we have visited it for the first time, I'll go ahead and mark it as visited. So that is basically Boolean as true. So if we take the case of 7 or let's say 3, 3 falls under 0, comma 1. So let me just write that here, 0, comma 1, right? So basically I is equal to 0 and j is equal to 1. That is as per the board that is represented by 3. But if you take a look at what we are saying in our business logic, rows of I of num, what it essentially means is rows of 0 and 3 is going to be marked as true. So basically, the idea here being that we do not have to preserve the order in any way. All we need to do is, if we are going to have that particular number at that particular row repeat, we are going to mark it as false. This is going to ensure that we stick to the rules of the uh, problem without having any difficulties. So we can do the same thing with the columns as well. So let me just quickly show you. If columns of j and num is visited already, that is if it is true, then we will be returning it as false. And if it is not visited, what I can quickly do is columns of j and number is going to be true. So we have done validation against the row and column as well. You can see one small issue with the code, not an issue, a small uh, uh, trick in the solution that we have actually employed is that we do not always check the first column. We are basically checking column of j and num. So let us say we are checking for the number 4 at 0th or the first row basically. So that basically means we'll be marking the column of 1 and 4 as true. So this need not always correspond to the first column only. It can be a different column within the first row, which is going to be irrelevant because we'll anyway be validating the whole Sudoku board itself. So that way we do not actually have to be under the constraints of validating only one column at a time. So another way that we can solve this is basically to invert all the columns into row and again validate them as rows individually, which works equally fine. But this method seems more easier to understand and approach and code it up as well. So now that we have actually been able to validate for the rows and columns, we can move over to the third condition, basically to check if the sub boxes of the grid contain the digit 1 to 9 without any repetition. So to achieve this, what we can do is come up with a approach to actually individually track all the 9 boxes. So as we can see here, at the end of the day, we just need to check if every single cell within this particular sub box is does not contain any sort of a repetition. So one way to visualize this is that we have a 3 by 3 array. Let us say, let me just mark this as a box validator so it's more easier to understand. Yeah, so this is essentially what I'm doing. This is going to be a Boolean array again, which is again going to track what exactly has been visited so far. So the idea is we have 3 by 3, which basically means there are 3 rows and 3 columns, and within each of these cell, is an array which contains up to 9 elements. So each of these arrays that are actually present here represents one single box. So as you can see, there are 9 boxes that are actually present in the system. So what we can do is, if you consider, let us say, an element 3 here, right? This is basically 1, 2, 3, 4, fifth box. So how do we actually do it? So it is actually quite simple. So our row count is going to be I by 3, and our column count is going to be j by 3. So for this particular case, as we can see, I is going to be 0, 1, 2, 3, and 4. So I will be equal to 4 and j will be equal to, just a second. Yeah. So j is going to be equal to 0, 1, 2, 3, 4, and 5, which is going to be 4 and 5. So if we divide both 4 and 5 by 3, we are going to come up with 1 and 1. So basically, this is the box that we are talking about. Since there are 9 boxes, the boxes index can be identified as 00, 01, 02, and then 10, 11, 12, then 20, 21, 22. 1 comma 1 represents the box at the middle where this particular 3 lies. So this is how it's going to work. This is basically the intuition that we need to figure out in an interview setting. And once we have this, it should be fairly straightforward for us to actually validate this. So let me quickly create a visited array to validate the boxes as well. So let me just name this as box validator or the box visited. So this is going to be 3 by 3 by 9. So what I can do next is, similar to how I have validated rows and columns, I can validate the box in the same way. If box validator of row count and then column count followed by the number is already set to true, or if it is already visited, I will be returning it as false. And in case it is not visited yet, then I'll be explicitly marking it as true, marking that it has been visited at least once. So let me quickly do that. And num equal to true. So this is essentially it. Once we have gone through the iterations across the whole Sudoku board, we know that everything is in place. All the validations have been successful. So we can essentially return it as true here. So this is basically how the Sudoku problem can be solved. Let us do a quick run to see if it is actually going across all the cases. I can see it has failed because I have not declared these variables. Let me quickly do that. Yeah. Yeah. So now we can see that all the cases are actually passing. So let me just quickly submit this. Yeah. So as you can see, it is able to successfully validate against the row, the column, and every individual box as well. So now that we have a working solution with us, let us take a look at the space and time complexity. This problem comes up with a constraint that the board is always going to be 9 by 9, which is why we literally used 9 rows and 9 columns for all the data structures that we created. Similarly, for the box validator as well, even if it's a three-dimensional array, the sizes that we have given is exactly as per the constraints, literally hard-coded. So basically, the space complexity is going to be O of 1 in this case. As far as the time complexity is concerned, since we are iterating from 0 to 9 in both the cases, at max, the loop is going to iterate 81 times, which is again going to be a objective number and not dependent on the board length in any way. So both the space and time complexity is going to remain as O of 1 in this case. But let's say the board was going to be more scalable. It need not be 9 by 9, it could have been anything 10 by 10, 20 by 20, whatever. in that particular scenario, since we would have iterated over the entire board, and the iteration logic would have been dependent on the length of the board, the size of the board, the time complexity would have increased to O of n square, compensating for both number of rows and number of columns, whereas the space complexity would have been O of n square. Obviously, the next question would be, since we have a three-dimensional box, wouldn't the space complexity be O of n cube? But basically, if you take a look at how the box validator works, we have 3 by 3 by 9. Essentially, if you have a 9 by 9 Sudoku board with you, then you will only have the number of sub boxes that you can create equivalent to 9 would always be equal to 3, which is basically the square root of 9. So let us say if the box size was 16, then the box validator would always be 4 by 4, 4 by 4 by 16. So if it was 25, it would always be 5 by 5 by 25. So there is a certain relation that you can see. So ideally, as far as the space complexity of box validator is concerned, it would have been something along the lines of square root of n multiplied by square root of n multiplied by n. So square root of n into square root of n again comes to n. N into n would become n square. So irrespective of how big the size of the box validator is going to be, our maximum space complexity would always come down to O of n square. So for the scalable Sudoku board, the time complexity would be O of n square, and the space complexity would also be O of n square.